Okay, everybody's ready? Okay. All right, so we're going to continue our understanding of the impact of generative AI, right? I mentioned that I will talk about the ethics or ethics-related problems. So what we're going to do is that we're going to start from some of the benefits and risks. And once we look at the benefits and risks, then we will continue to look for the ethical problems that we have. Okay? Another thing I mentioned yesterday was that I'll try to get some videos. I couldn't locate the video of that robot that I mentioned. It's probably like 9-10-year-old video. I'll see if I can find it. But I'll show you a couple of autonomous car videos actually that are out there. So you'll see the benefits, you'll see the risk, you'll see the ethical issues there as well to some extent. Okay, so before I continue, any questions from yesterday or even before? Anyone? Okay, so what we're going to do for tomorrow, and I'll say that now itself because we will have, I think we have a hard stop when you want all of these to go visit the STPI. So what I'm going to do tomorrow actually pick up some of the things that some of you asked for. One was, I don't know if you guys are there or not, those who were doing the remote sensing and GIS related work. Okay, there you are. So I'll cover a little bit on that topic. A couple of you who wanted to know more about how to create an LLM from scratch. So I'll cover that as well. In addition to whatever I had originally planned, which was more on the regulatory stuff. We'll touch base on regulatory stuff today. But we'll continue that conversation tomorrow. Also bringing in what India is doing actually, or where India is right now. There are a lot of developments that happens. Words moves very fast. There is an electronics show that is happening right now in Las Vegas, which is where all these tech companies introduce new announcements. OpenAI made an announcement, Google made a lot of announcements, NVIDIA made a lot of announcements. I'll see if I can get something of interest for you guys tomorrow, but there's a whole lot of conversations and a whole lot of new announcements that have happened and are happening as we speak right now. Too late now actually, it's way too late right now, but happened earlier during the day. Okay. One more opportunity, any questions before we start? All right, so let's start with the benefits and the risks, right? We covered a lot of these things. I'll say one thing actually, because these slides I put together late last night, so they're not probably as polished as the other ones were, because I kind of juggled around a few things based on what you guys were asking for, and then combined something from which I was supposed to do tomorrow or today, and then all kinds of things. So hopefully they're readable and they'll be fine. So in terms of the benefits, we've been talking about it at least for the last 2 days, right? It started as the prediction of the next word, but found its application in a lot of different areas, right? Enhanced decision making. We saw an example. We actually defined the fraud detection. We defined the money laundering detection. A lot of other decision making in terms of potentially in the healthcare world, monitoring healthcare situations, suggesting what best can be done. Increased productivity, that's another big area. Many of you have actually utilized it while you're doing programming. A couple of you gave me an example that you are using the ChatGPT to improve your writing. So you write your first draft, you ask the ChatGPT to improve. So all around increased productivity, many companies have reported that is happening. Cost saving. In many cases, if it is a routine generative work, it has been assigned to ChatGPT. Writing emails, developing marketing copies, writing out email marketing content. A lot of content generation has already been given to some kind of a LLM ChatGPT or otherwise, right? If we continue on that, personalized customer experiences, whether it's personalized marketing, whether it's personalized reminders, whether it's personalized kind of whatever the user interface you want to look at it. The customization, which is more driven by a large language model rather than driven by the rules. So one may argue that the customization of the customer experience already exists. Yes, it does. But majority of it is based on rules. Majority of it is based on some algorithm. Now we are using the language models to really drive that. There is acceleration in the research and development for multiple reasons, actually. You're doing a lot better searches. You're doing the summarization rather than initially starting and saying that I'm going to find out 50 most relevant papers in my area. You can actually have a large language model agent trained to search around and find the relevant papers for you, maybe potentially generate a summary. Now, these summaries are not necessarily very accurate, and there's a lot of work that still need to be needed to see whether the summaries are really doing good, but it's a good starting point. There's also research and development in the area that we talked about yesterday in the healthcare, pharmaceutical development, molecular reactions analysis kind of thing. So there's a lot of area where it's actually being utilized, right? Mechanical production lines where robots are involved. Robots are now getting better so that they're not necessarily rules driven, but also driven by the language models, right? It's creating new jobs. Definitely it's creating new jobs. Like a lot of people are learning about prompt engineering. Prompt engineering, no one had ever heard of this like 5 years ago. So that's a brand new area that we have. Labeling of the data for supervised learning. There are companies in India, I know a few which have actually have $1 billion evaluation in terms of all that they're doing is the labeling of the data. Anyone has heard of the company name Atlan? It was started about 5-6 years ago. A 28-year-old girl, I would say, or a female. And then at the time when no one had heard of that, there could be a company whose sole job is to provide label data. She kind of realized that there will be a need for supervised learning, and there will be a lot of potential for an Indian company with relatively cheap labor available to really train the these language networks or language models for supervised learning. So there's new jobs being created. Will the jobs be impacted? We talked about it yesterday. Yes, but that has happened every time there has been a major technology change. We looked at 3 examples, right? Printing press, and then we looked at when the Industrial Revolution happened, and we looked at when the internet came along. Things change, right? We had an example of, what was it? Video rental shops. Those are disappeared, right? People who were running those jobs have to find something else to do. So there will be some jobs which will disappear. There will be some reskilling required, and we'll talk about when we come to the risk or the dangers of it if we have not already talked about it. Some recommendations for stakeholder. We will review this tomorrow again when we look at the regulation part of it. There's regulation stuff related to some of the ethics and privacy related issues that I'll cover later in the class. But in general, establish government framework, because if the regulation or governance framework, if the regulations don't exist, we have a problem, right? We talked about it a little bit yesterday. We'll continue to talk about it today, like what kind of problems exist, risks, ethics, and those kind of issues. Invest in training. That's undeniably required. Governments have a role to play in it. A lot of people would see that their current jobs will probably be negatively impacted. They need to be reskilled, retrained in the new set of skills that need to happening, right? Continuous monitoring. I mean, things are changing, they are evolving, they need to be monitored, right? Okay, transparency, we're going to talk about the transparency as well. Now, transparency from two different perspectives, we're going to look at it. Algorithmic transparency in the sense that what the logic is being used, and also the transparency in how the model is arriving at a conclusion. So that's what we're going to look into it, right? Benefits. What are the benefits? How many of you think that a driverless car is an offshoot of a language model, or at least a deep neural network? Right? I'm going to play the video. Actually, I've a few of them from last couple of months, and you would see that how the driverless cars are actually working. Let's see if it works. For any questions, press the call support button to speak with a rider support agent. It's starting right now, so you see it's merging into the traffic. Traffic is going on. There's enough. For any questions, press the call support button to speak with a rider support agent. Okay. There's another one here. You see it in the traffic. Actually, this one is on the highway. It's probably traveling around 30, 35 miles per hour. Switching lane and then stopping. Okay, and another one, which is in the city traffic. This is why on the left-hand side, but this one. Also, oncoming traffic. Public, you will see a couple of faces, my younger son and his friends. Ignore that. The bus passing by. The truck crossing and it stops. So, all of it is happening using everything that we have looked at in the last few days. There's a deep neural network running. There is a central location which is monitoring. I had another video where somebody is monitoring the ride and things like that. In the real time, it's scanning. There are sensors, and then it's going through the deep neural network to identify the objects, the distance between them, etc., etc., etc. Okay, any questions? The best thing to do is to see this and then realize that how exactly this was happening or how exactly this was being done, right? So, any questions? Otherwise, we move on. All right. So, yeah.
So I want to ask now about the benefits of Gen AI. So, what are the benefits of Gen AI for the adaptability of the same for rural people?
Okay. Now, this is something we talked about yesterday in terms of that, is it going to increase the gap between haves and have-nots, right? I gave this example yesterday from a couple of different perspectives that, yes, you think you're getting benefits, but how about those who don't have the access to these tools, right? Adaptability. Will this increase the adaptability of usage by the not so, let's say, the people who have not so closer access to this? The key to that is the use case, right? Personally, I think with the advent of smartphones, there's a high likelihood that everybody will get to know about it, right? Also, the social media has made almost everyone who has a smartphone as a consumer. So we looked at two things. As a consumer, people are consuming the video and they're also distributing it because they're able to send it out to their network. Will they be able to create the content? I don't think we are there as yet. I think the key question about adaptability in terms of it will be use case. Personally, I think the first use case would most likely be in the healthcare. Now, I'm biased a little bit because that's my current area of interest as well. But I think that probably would be the first use case. Let me tell you, lot of things that we have been talking about 40 years ago when I started, telemedicine was a huge kind of like a thing that it's about to happen in 5 years, in 10 years, hasn't happened yet. I think with the language models and some kind of smartphones didn't exist 40 years ago. The communication was really weak. So things can happen probably in telemedicine a lot more, in the sense that you don't need to visit a doctor or a hospital for a minor cough, cold related issue, for example. Even in US, COVID made a lot of, I would say, behavioral change. Earlier, even in US, people were not necessarily very receptive to talking to their doctor or nurse remotely. Everybody wanted to visit and see in person. I think COVID had a lot of negatives, but there were a lot of positives. I think when the first time people were kind of willing to buy things online without seeing, touching, or trying them on, that led to e-commerce. After that, people were willing to kind of share their photos and videos. A huge Rubicon was crossed, in the sense like, rather than saying that this is my personal information, people were willing to share on a network. That was another huge behavioral change that happened. I think the third behavioral change was during COVID, at least in US, where people thought that they can consult a doctor remotely just on a video call. So that has happened. I think in places like India, where access to the healthcare is still a huge problem, that might be the use case that would increase the adaptability or usage. Again, that's just my view. All right. Any other question?
I will take 1 minute time to fix it.
Okay. Okay.
So you continue to talk.
Perfect. All right. So any other question from anyone? Okay, so what we're going to do while we get this set up, hopefully so we looked at the benefits a little bit. I showed you one example of autonomous vehicle, which is a huge application area for AI, neural networks, and the language models as well. What we're going to do is that we're going to talk about the risks. So think of it, what the risk you might assume. We talked about them last few days multiple times. So what could be the risks? Any ideas? Okay, so while this one is coming up, I posted another case study yesterday, right? Has anyone looked at it? What we are talking today and tomorrow should help you form your opinion. No right or wrong answer. It's a situation that is talking about India very specifically, right? Maybe something less, yeah. Perfect. Okay, so what risks do exist?
Security.
Right, security is one. What else actually?
Again, coming to maybe ethical concerns are always there.
Right, but before that, actually, fundamentally in terms of the functionality itself. If you think about it, we have been a little bit woolly-eyed in the sense that all is well. If LLM says something, it has to be right. So let's introduce a term here that I've not used it before, and let me know if any of you have heard this: hallucination. right? What does that mean? And what is it that you have heard about in the context of language models?
It's something like when LLM tries to figure out, but not accurately and giving some wrong information.
Right. So it gives the wrong information not because it wants to give the wrong information, and I'm going to differentiate between the two cases. We saw that there is a possibility that someone can corrupt the model itself by actually hacking the prompt or by actually giving it some bad data. And because we know, and if we know, then the bad people also know that once model makes one mistake, it is not easy for it to recover. It's going to bound to make more mistakes or more egregious mistakes, right? So one of the issue that we have, or the risk that we have, is that model hallucinates. It basically gives you either bad information, incorrect information, not because of malicious intent, but just because it doesn't know any better, right? So think of it, what I'm saying here. For last 1 week, I'm saying that the model is showing sentience. It's discovering relations that no one has told it. But it's also discovering relations which don't exist. Because really speaking, it's just creating association and finding probabilities. Because it hallucinates, and it hallucinates a lot more than you can think of. So what's the implication? Can't take anything and everything that it says at a face value. You have to make sure that the model is doing the right thing. You can find out, ask the ChatGPT about yourself. There is a high likelihood, it's getting better. Earlier versions, 2 and 3, it would give you the wrong information because it's trying to find the probability of, in the earlier days, last year, it would show me that I'm working somewhere in California because it's predicting some numbers, right? Or predicting the probability, and it finds that in my history somewhere, it sees California because I was in California. So it just throws in California randomly somewhere. So all kinds of mistakes that happen. Air Canada has a chatbot. The chatbot was telling Air Canada customers wrong policies because it was making up policies as. So these are the risks in a way. It hallucinates. You want chatbot, which is not rule driven, but what if it cannot find the answer? By nature, it will generate an answer. So it made up the policies, it made up the rules, and Air Canada had to take it back. And those people, those users who actually acted based on what Air Canada chatbot was telling them to do, sued Air Canada and won in the court. So that indicates the issue in terms of the responsibility. Who's responsible in that case? Court determined the Air Canada is responsible, but Air Canada also needs to find, is it data, is it model, is it programmer, is it developer, who, right? This may not be such a huge case. I think they lost a couple of $1 million, fine, but it could be fatal. People can lose lives. Wars may start between two countries. Wrong intelligence can lead to anything and everything, right? So hallucination is an issue. We will try to look at it tomorrow a little bit, but not necessarily too much in detail. Copyright protection. The content creators did not know what these large companies are doing, as generally you did not know that you are providing the label data for companies like Meta and to some extent Google, right? I gave you the example, two examples where all of you have contributed in building these models. Every time you solve a CAPTCHA problem, that's a label data for a large language model to use. Every time you tag your friends in your Facebook photo or Instagram reel or anywhere, that's another label data that is being used. But beyond that, these models have also consumed everything that's written by New York Times, everything that's written by any newspaper, right? All the publicly available books and things like that. Now, all of these people are trying to figure out is it a violation of copyright? In some cases, there are artists which have claimed that their intellectual property right has been violated because language model produced an image or an art which was very close to what the other artist had produced. Now, most of these problems are unsolved. The cases are out there. The courts have not taken a position. So there's always a trade-off in the copyright laws. I mean, we're talking about the intellectual property laws. So there is a copyright, which means that the person who has generated or created a piece of art owns the rights to that. But, and I'm talking this from the US court's perspective, but I'm sure India will probably have something very similar. All copyright laws do allow a fair use exception, where what we say in the sense that, yes, you own the copyright, but if we want to use it in a fair kind of situation, then you are allowed to use it. So all these court cases are trying to figure out, is this an infringement of intellectual property right of the original creator, or will this use, training a model utilizing their work, comes under fair use? So that's the law that's going on, right? We talked about privacy earlier as well, so that's another issue. Because these models have been trained on all the data that's available in public domain. How many of you know that when you send an email, it's a public data, or anyone can see it? You know it or you don't know it? When you send an email, you have no idea how many servers it's traversing, what route it's taking, how many places a copy might be left, and how many people can actually scan the email. Have you ever noticed you send an email to someone and those people write their email addresses like this? Have you ever seen this? Right? Because hope is that someone who's scanning will not steal the email address just like this. Because if they are scanning to anything like name at company name dot 3-letter domain, they would be scanning for this and trying to find the email address. If you do it this way, you're trying to fool. But again, even this is not foolproof, right? People can still. That's why you may have also noticed that if you have a bank account or something, they'll say that don't send any personal information in an email, because email is all public information. By design, it's that way. Will the things change? They may change. There are secure emails. There are systems which actually send the secure emails. Really speaking, what they do, has anyone used the secure emails kind of thing? So what the secure emails are doing, actually, they're not sending it as an email. So what you're doing is that you're talking to a server or a company or an application, and your email is stored there. The person who is supposed to receive it gets a proper email, normal email, open email saying that you have a message here, and then you authenticate yourself based on some ID, password, or a token, or OTP, whatever the case may be, and then you get to see it here on this web page. And this email might disappear after 24 hours or something like that. So there are secure email systems that are being used, but your emails is out there. Models may have already learned it, and they may also kind of leak it. Same is true, not just your email address. Anything you ever said in a public email can potentially be disclosed by a large language model somewhere. Okay? Toxicity. Now that's another term that's being used. I gave you an example. This was the example, I think. We'll see it one more time. This is the Bing example, but there was a chatbot that Microsoft introduced, and it learned toxic behavior very quickly. So that's another problem, that these large language models, which are, because they can learn, they are always learning. So if you think about it, there are no two separate modes, that are learning mode and generation mode, right? We talked about it a couple of days ago that even though there has been unsupervised learning, you can still provide it supervised learning as part of prompt engineering. So any model is not that it had a learning phase and a separate generation phase. While generating, it is still learning. We saw that every time it predicts a word, it executes it again. It learns that. We saw that when we were looking at embedding, every intermediate sentence or text becomes a new embedded token. So it's always learning. That takes us to the potential risk of toxicity and abuse. The models can be led to a toxic behavior by someone who's malicious. As an individual, you may not be interested, but as a brand, let's say if I run a billion-dollar company, or let's say I am whatever the best company you can imagine, and we're trying to make use of large language model in our business, we need to think through all these risks and then make sure that what is the guardrails. That's another term that's being used. The guardrails basically, has anyone heard the term guardrails in terms of the language model? Guardrails is a term that defines that let the model not make these mistakes. So they create these guardrails in terms of, there are multiple ways. We talk about a few of them later today in terms of making sure that the language models don't make these kind of mistake. No abuse, no toxic behavior, no disclosing the private data, no hallucination or as little hallucination as theoretically possible. All of those are part of creating these guardrails basically. All right. So let's just very quickly review the same way we looked at the benefits. Bias and misinformation, we talked about it yesterday. We're going to talk about it going forward a little bit in the next hour or so. Cybersecurity threat, we also looked at it yesterday or day before, that any cybersecurity situation that you can think of in other systems also exist here because you are interacting with them. All the same problems exist. Privacy concerns, I gave you an example. So think of it this way. There are two things here. There is not a new privacy concern. You're sending in the email, you're writing an email. There's a high likelihood that no one bothers about your email. A bad character may still do it. Problem with the large language models is that they made this risk more obvious because there are more people interacting with language model, and then your language model can inadvertently show your personal or private data, right? Legal risks, same thing in terms of either intellectual property right or hallucination, whereby your model is misrepresenting your policies, misrepresenting your whatever the rules or rules of business that you have. Environmental impact, we talked about it briefly. I mentioned to you that a couple of big companies, Meta and Microsoft, are both buying nuclear power plant because their electricity demand is so big that in the next couple of years they won't be able to get it from the grid in US. So think of it, how high the electricity demand is for these things. Water demand is also very high. Now water demand is high even today. Electricity demand is new because of these new chips that are being used. A lot of ethical considerations, which is obviously is the topic we're going to talk about today. Okay, any questions in terms of the risks? It was pretty much a summary, except that I introduced a couple of new terms: hallucination, guardrail. What else? I think there was one more. Any questions here? Okay, if not, for the next hour, let's talk about ethical considerations in generative AI. So, most of you must have done a course on ethics somewhere, right? We tried to define it ethics, but Let's try again. Anyone who wants to take an opportunity to say what would be the definition of ethics or ethical considerations for generative AI? Yes?
Anything which is in accordance with the rules and regulations or the principle of humanity.
Okay, so two parts of it. Unless you bring the humanity, I would have asked the question, is everything that you do by rule ethical? Sometimes not. You could be following the rules and regulations, it may still be unethical, right? So you are legally allowed to do certain things, but ethically they're not good or morally they're not right. Why I left the humanity part? Because that is a very open statement. I agree with your intent there or with your direction there, but the problem is that we may not have codified that. And actually that's the problem we are going to deal with, in the sense that what are the set of principles and practices that these language models should focus on or should be cognizant of to make sure that the AI techniques are used in the right way, not in necessarily incorrect way. Right? So when we were looking at the history of the artificial intelligence, right, I mentioned that the research started in 20th century, 1940, 1950 time frame. Surprisingly, the ethical considerations were also thought through at that time. How many of you have heard the name of Isaac Asimov? No? Nobody is a sci-fi fan here? That's surprising. My generation, Isaac Asimov was like a fairly common name basically. So Isaac Asimov basically was writing the futuristic novels, sci-fi, in 1970s, 80s, actually even earlier as well. Most of the Star Wars was imagined by Isaac Asimov. Robots were imagined by Isaac Asimov, and some kind of a super intelligent creature. How many of you watched the Star Wars? Okay, that's all influenced by Isaac Asimov's work in one way or the other. So the first person who, if you think of thinking in terms of the ethics of the AI or machine learning, was Isaac Asimov. Not in the way a scientist would do, but he was a sci-fi person, right? He was imagining things, or he was kind of, so he had some rules basically. What should a robot do, or what is an ethical behavior for a robot? Think of it, this is I think in 1940 or 1950. So this was 1942. 3 laws of robotics. There were no robots at that time. So imagine like somebody's writing, it's a fiction, it's a sci-fi fiction, and he came up with these 3 laws. A robot may not injure a human being through interaction, allow a human being to come to harm. A robot must obey the orders given it by a human being, except where such orders would conflict with the first law. Must protect its own existence as long as the protection does not conflict with the first or second law. All sci-fi movies which have where the robots actually have revolted or have gone against the mankind actually seems to be violating one or almost all these laws. So theoretically speaking, something which Isaac Asimov was a scientist, by the way. He was a scientist by profession, but he was also a sci-fi fiction writer. So this has been treated now, just not if you replace the robot with a language model or a machine which has done the learning, these rules apply. And as a matter of fact, practitioners in the field of the machine learning frequently use these rules to say, if this application, if this system, if this machine follows these rules, it is supposed to be acting ethically. right? Couple of you asked the question, what if the robots kind of do the bad things? They would be either violating 2 or 3 or maybe 1 or all of them. So those are kind of rules which are going in terms of the ethical behavior of a machine which is intelligent. Call it AI, machine learning, language model, whatever the case may be. Not much work happened in post 1950. If you remember from the day one, I used the term AI winter. Lot of false starts, logic systems, expert systems, rule-based systems, decision-based systems. People thought multiple different ways to create AI systems, none of which succeeded a lot, right? So the next recent work has happened only in the last 15, 20 years when the neural networks were kind of discovered. This is an open topic, actually. What led to the success of the neural network in 2000? I think the jury is still out in the sense that, because if you think about it, neither the fundamental building blocks that we talked about, neither the perceptron, nor the back propagation, not the feed-forward network were discovered in the last 20 years. They were all known. So, was it something else that caused the neural networks to work? Was it data? Was it computer? Maybe everything together, right? So it's still out that which was the one pivotal moment. I mean, clearly, scientists saw that if you increase the amount of neurons, that's where it starts learning, and it starts learning the latent space. So clearly, everything together caused it. But anyway, so this renaissance started looking at, and it says advancement in machine learning, big data, increased computing power, everything kind of came together. And then we started looking at in terms of transparency, fairness, trying to look into the biases in algorithms. As a matter of fact, actually one of the course I probably would be teaching in coming years, this is still being worked, is called Biases in Algorithms and Data. So we'll talk a little bit about biases today as well, mostly in data, but then algorithms also have bias. There's a potential the algorithms may have bias. So all of that has become active in the last 10, 15 years and things like that, right? More recent, if you think of last 5 years, we have started seeing something called responsible AI. Now, what does it mean by responsible AI? That it is keeping track of your privacy issues, it's keeping track of some security, it's following some regulations. The governments have also kind of opened up and then trying to build some frameworks. Nobody has all the answers. Governments are also learning, trying to see how privacy, security, performance, functionality all have to come together. We'll look at some examples today or tomorrow, right? So, if you think in terms of the ethical considerations, what do we need to do, right? So if you think about it, there are 4 major areas that we're going to talk about today. Avoiding bias, because we have seen this. We have seen this that because the models are learning from our existing data, anything that's in the data, whether it was 1800 practice, 1900 or early 2000 practice, is all learned by the model. How do we avoid those biases? Privacy concerns. Because it has learned all the data, because a lot of information is already public even without us knowing it, because a lot of information we are providing to these models by actually naming people in our photos and videos and things like that, privacy concerns. Accountability and transparency. If something bad happens, who's accountable? Transparency is a related subject in the sense that how did you reach to that conclusion? It could be something that law and order using a face recognition technique, using deep neural network. Law and order is using remote sensing or a drone photography to identify someone who has done some bad things. All of it require transparency because it will be challenged in the court. Right? You saying that the large language model is telling that I am XYZ, but what makes you think so? Same thing in terms of transparency is that if a large language model is used to help in suggesting a health outcome or a health prognosis or a diagnosis or a potential medicine or a treatment plan, there will be questions that how did you actually reach to this answer? So transparency is important. And finally, environmental impact. As I mentioned that these models are not cheap. Training them require a lot of money. Executing them require a lot of money. If you remember that every time a next word is predicted, it is doing a billion calculation, right? So they are expensive. None of the company which is involved in the large language model, except NVIDIA, has made money. Everybody's losing money right now. Only NVIDIA is making money because they are providing the chips. So they're selling it at whatever price they want right now. All right, so we're going to look at these 4 issues in, let's say, next 40 minutes or so, roughly 10, 12 minutes on each of these topics, and which is what the bulk of the work today is. If you have not read through the latest case study, it is all talking about bias, privacy concerns, accountability, transparency, not so much on environmental impact. So you would find, hopefully, the conversation today. Feel free to ask questions if you have. I would not answer anything related specifically to the case study because I want you to think through or think about it. But if you have any related kind of thought that comes to you as we discuss the first 3 topics here, feel free to discuss that, right? Okay, so let's start with bias or bias and fairness. The bias could be in the data, it could be in algorithms, it could be in interaction itself. So let's say, okay, we go into the detail. What we need to see is that be aware of how these biases manifest, because unless you, there's an old saying, unless you measure, you can't fix it. So first thing you need to do is to make sure that you identify that biases do exist. Once you identify, then you may take action, which is a remedial action. Can we have the fairness metrics? What define fairness? How many of you have had a fight with your teacher, professor, instructor saying that, oh, I didn't get the X number of marks that I was expecting in this paper, and your teacher says that, no, you got the fair marks. Point I'm trying to make is that fairness is subjective, right? In any transaction, one party may think that outcome is fair, the other party may think that it is not fair to me, right? So what are the fairness metrics that should be used? Because fairness is subjective, unfortunately, in majority of the situations. What are the challenges of implementing fairness in complex AI systems? Because if we do not have a universally accepted definition of fairness, how do you even enforce it? Right? So, ethical problem, right? Because there's no right and wrong answer. Inclusive AI development. Now, this started primarily from the bias perspective, where one of the way it was thought that if you have the AI development teams white male only, the hidden biases or biases will automatically creep into whatever they are doing, either in terms of algorithmic bias, interaction bias, or in the data bias as well. So one of the things, as a matter of regulatory change, most of these companies are doing that, more so in the AI teams than in other teams, that the teams are inclusive. Inclusive from gender perspective, inclusive from the race perspective, inclusive also from the geographical distribution perspective. So from all perspective, that's happening as well. So let's go into a little bit more detail here. Biases and fairness. What is data bias? So if you think about it, let me just give you an intuition from mathematical perspective. Everything is a function. if you are training your model on a function which is different from what its target audience is, you have introduced a bias. You have introduced a bias, right? The example here is that if a data set predominantly has images of lighter skinned individuals, because that's, let's say, the early adoption of the social media was, then invariably it would perform badly on the images of people from darker skins, whether it's Africa, whether it's Asia, right? That happens. Lot of medical AI, which is using skin colors to really discover or determine health related problems, is either not working or incorrectly predicting if the target population is not the lighter color skin but a darker color skin. That's a problem, right? So that's a bias in the data itself. Okay? How about algorithmic bias? An algorithm may be designed to use certain features which may not be on their own directly having a bias, but indirectly having a bias. Right? Can you give me an example? Can you think of an example? So, let me give you an example. I'll try to kind of use it in the Indian context, but make it slightly differently here. So, let's think of it. I'm going to take the example from Allahabad or Prayagraj, and let's see if it works out. So let's say the government has a regulation for some system randomly, right? That this system should not discriminate, right? And it says that you cannot use a person's wealth to determine whatever the outcome is, right? And then as a developer, you said, great, we are not going to use your bank account, we are not going to use your salary to determine whatever is the outcome. And you might say that we are not introducing a bias in the outcome based on your wealth. Wealth means both wealth, which is accumulated, and as well as income, which is earned, right? Great, perfectly fine. But let's say this system is utilizing your address. Anyone sees a problem here? Yes, no, maybe?
Since the data point is address, and it's a rudimentary understanding that most of the high wealth individuals live in upscale neighborhoods only.
Correct. So there may be that it is using an attribute which is indirectly giving you an idea about the wealth. So there is a possibility that the algorithm itself is using a feature which is introducing a bias inadvertently. Right? So that is a possibility. We'll see some regulations which are trying to work with that. Unfair outcome because favoring one group over another. So that's a problem or an example of an algorithmic bias. Interaction bias. Because the models are always learning, if you interact with one set of users, and which was the example with this Microsoft chatbot, a group of people, there were not too many, very few, coordinated interaction with the chatbot much more than a normal interaction would or normal group will interact, and made it learn the toxic behavior very quickly. Now that's the interaction bias. One may argue theoretically that it should stop learning, but that defeats the purpose, right? The whole idea for it is to continuously learn. All right, so we looked at the examples of the data bias, algorithmic bias, and the interaction bias. The next thing that we want to talk about is the fairness metrics. How do we know what fairness is? There's no hard and fast definition, no absolute definition. Different definitions exist. There is no universal metric, so really challenging, right? What do you think is a good definition of fairness? I can reframe the question from a lot of different perspectives, because I'm sure almost every one of you has come across this problem or this situation. You may not have thought in that terms, or you may not have realized it in those terms. So let me see if you can answer. I can reframe this from the perspective of CS students, how you have seen fairness, or even the management students, how you have seen the fairness. Who can take a shot on defining what you think is fairness? Fairness is. Come on. Let me ask the CS students. Have you ever come across the fairness issues?
Fairness means like treating equally.
Treating equally. That's a noble objective.
More like transparency, there must be transparency.
Okay, we're going to go transparency separately. We are only talking about fairness right now. You said something very interesting. Treating, what did you say? Equally. Very important topic. So instead of having only two ways defining for computer science students and for management students, let's bring sociology or political students. Anybody with sociology and politics interest?
Sir,
Yeah.
there was an issue in fairness when I was working on a stress model. So it was giving the higher weightage to the nervousness state rather than other levels. So it was not fairness that I was expecting from the model.
Okay. Fair response, but here's what I would say. That's more in the difference in expectation, not necessarily fairness. So let me just take this as an example, and this is the third situation. I didn't want to introduce it myself. What is treating equally means? So let me take an example of this class. Is treating equally means giving everyone equal amount of time? Or is treating equally means giving more time to the person or student who is not understanding? Or is treating equally means giving more time to the person who actually understood everything and has more questions? Which one is fair? Which means that you are ignoring those who are not learning and those who are learning faster than everybody else.
Actually, all of these, maybe are right in different kind of.
Yes, that's where we started, that there is no universal definition of fairness, right? Now, you said treating equally. This is a typical problem in US, it's called affirmative action. In India, it's called reservations. Right? Is that fair? So the issue is, in general, no, we're not going there in that. I'm saying is that from fairness, if you define fairness as treating equally, the problem now becomes, what is equally? I gave an example of treating equally in the class. Is it fair or not? Here what happens, and I have gone to, this is the third example because you brought it up. What is equal? Is it equality of opportunity, or is it equality of outcome? if all of you are listening to the same lecture, potentially, let's say, spending same amount of time learning or solving problem, is it fair that some of you get higher marks, the others don't? Right? So, fairness from equality, is it equality of opportunity or is it equality of outcome? How many of you think that there should be equality of outcome? Everyone should get the same grade. That's not fair either, right? Equality of opportunity. Should I be spending more time with those who didn't understand and need more of my time? Or is it unfair to the other people that I'm spending more time with those people? Even this is not fair then. Right? That's the problem with fairness. For computer science students, whenever you've done operating systems, right? Round robin, what is that? Being fair to each process. Time sharing, you basically allocate one cycle to one process, the other process. Those are all the implementation of fairness, right? Lot of different ways you can talk about it. So the question comes back here is that what should be the fairness metrics for our large language models? Unless we define it, we can't implement it, right? So a couple of different ways, just like I was coming up to equality of opportunity or equality of outcome, lot of different matrices are being experimented. Equalized odds, demographic parity. Now, equalized odd is another thing. If you realize that this is basically, we are trying to say that we're not guaranteeing this, we're not guaranteeing this, but we are basically saying that a combination of these two will be fair to everyone. Right? I mean, one of the things that we do, I don't think there are grades here. You get the absolute numbers, right? You're 43% or 68% or 71%, right? You get grades? So no more numbers, 83, 84, 91, not anymore? Okay, all right. So I don't know how exactly is that working, but the grades is actually equalizing the odds. That's what is happening. So what is happening is that if I am actually spending more time with people who are not understanding, so by spending more time, giving them more opportunity, but not necessarily ensuring the same outcome for them, what I'm doing is that I'm equalizing the odds, right? So in a way, we're not going into that detail because that's more of the education. Two of the definitions that have been attempted there is the demographic parity or the equalized odd kind of solution. None of them are perfect. All depends on how exactly we are going to utilize these models or what is the intended use case. Some definitions of fairness will work in one use case but may not work in the other use case. Assuming we've got defined the fairness, right? Let's look at is how do we discover the bias. Now, if we have defined the fairness, the bias would be not every group has equalized odds, or not every group or individual has parity across the entire population. How do we detect it? So, techniques for detecting, you could either pre-process the training data, you can run tests against the algorithms, you can adjust the algorithms, you can post-process to see did the response was equally distributed across whatever the target function is, right? A lot of different ways. Challenges, we talked about incompatibility of metrics. You could think of something as fair, but when it comes to the actual use case, the intended user community did not think this is fair, right? Not a unique problem for language models. Everywhere it happens. You all have seen this. There's no right or wrong answer for any reservation debate, right? Something that would be treated fair by one group will be treated as unfair by another group. So no definitive answers. We are still doing it. I think that the student is not there. She says humanity. That's the problem. We can't define it. We don't seem to agree with what does that mean. So trade-off between fairness and performance, this is something which we will keep coming back to. More you try to be fair, more you require effort in terms of performance, more costly it becomes. We're going to look into that again in terms of the privacy matters as well. All right, let's just continue on this here. Privacy and data protection. We're going to stop in about 25 minutes because, so I'm going to go a little bit quicker here. Data privacy, regulatory framework, privacy preserving technique, something that I mentioned yesterday about differential privacy and federated learning. We'll talk a little bit more about these things. Very active area of research, both of them. So we can talk about that a little bit more. Privacy is an issue. We have seen the example. Majority of the training happened on the data that has been scraped from web or anything that's publicly available, your emails, your documents, your uploads. You uploaded a document somewhere, it's available for anyone and everyone to see. So because that is the source for these models, there is a risk of leaking this information about you. Not knowingly, sometime unknowingly, sometime a person with bad intention can actually train the model to do research about you, to do a reconnaissance about you, in the sense that I create an agent, I am targeting these 5 people, my agent is always looking for any information it can find about these people. Theoretically, it's possible. You can train an agent that will continue to do this forever. Okay? There is a potential for leaking personal information because the fact that the model has it makes it possible that the model may leak it. So that's always there, right? Performance and privacy preservation. If you are trying to reduce the risk of leaking personal information or ensuring the privacy, it adds the cost, right? A typical trade-off. I'm sure you have heard this term a lot in computer science. Space-time trade-off. When you were doing the algorithms, for example, you trade space for time or you trade time for space, right? So same way here. If you're trying to make it more cognizant of not leaking private information or preserve privacy, its performance may suffer or the cost may go high. With me so far? The other part on privacy and data protection is driven by the regulation. I mentioned GDPR yesterday and there's a CCPA. There are 2 regulations I'm going to just very quickly talk about a little bit. GDPR is called General Data Protection Regulation. What it says is that any company which is asking for personal data, and they have defined what data is personal data, there are about 15 or 16 attributes about you or any user, the company has to do a couple of things. First, it needs to explain why it is asking this data from an individual and how exactly will it use it. Those 2 things. And then the third thing, you as an individual have to provide a consent for both things. A, that you are providing the data, and B, you agree or consent to its usage by the company which is asking for this data. That's what the GDPR is doing. Strict guidelines for processing. User consent is important. And the final thing is right to be forgotten. This does not exist even in US today. What it means is that, let's say I am a Netflix user. Netflix has the entire history of what I have watched. I cannot ask in US Netflix that I want to be forgotten. Please remove all the data about me. GDPR enforces any company that is formally doing business in Europe, in EU countries, they need to provide a way to be forgotten. Now that's something new as a term that you will see. Amazon has the entire history of what I have ever purchased. Not only it has history of what I have ever purchased, but what I have ever searched on. Google has the history of everything that I ever searched on. If you are using the Android map, Google has a history of every single place that you have ever been. There has been an instance when someone was arrested and actually put on a no-fly list. Why? Because the government systems find that that person was at the same place, let's say within the 10 meters, 25 meters, I don't have the exact numbers, vicinity of a known terrorist over multiple period of times, right? Correlation or causation. It could be a coincidence also, but then they were going by, once it's coincidence, second time it's maybe chance, third time is not necessarily. So they were saying that we discovered that this person is a terrorist, you, X, Y, and Z, in last 2 years, 10 times in the same vicinity when this person was. Right? The models can do that. That's basically the guidelines in terms of data to be forgotten. Google is now allowing it. The Google is now saying that if you want to be forgotten or if you want us to remove all your locational history, you can ask for it. I mean, because they're doing it for the Europe, they're also doing it for the Americas. I don't know if they have done it here as well. A lot of more Android users here than anywhere else. So think about it. All these companies know it. The models will eventually know it if they want to know it, and they can figure out, right? It knows where you've been, what searches have you done, what have you bought, what you actually put into a shopping cart but did not buy. All of this information about you is known, right? What social media posts you made, what social media posts you liked, what social media posts you made a comment on. So a lot about you is already known. CCPA also has a similar consumer rights in the state of California. There's a little bit of a difference in the US and India. In US, states have a lot more power compared to the India here. So, and state of California is usually way ahead in terms of regulations, right? So, if you, those of you who've been, or if you ever get a chance to visit California, it's not different from a nanny state in the sense that it is such a highly regulated place, both for individuals as well as for the company. I mean, if you want to put a flag on your home, you can't do that unless you get a permission from the township first. I mean, majority of you probably know America being the place which is the land of free, but I can tell you that this is a place which has such high regulations. So, for example, place where I live had a snowfall yesterday. So there's a regulation. I have a responsibility for the entire sidewalk in front of my house to be cleaned. Within 4 hours after the snow stop, I have to make sure that it cleans, because if someone slips and has a medical situation, I am responsible for paying for that person's medical bill. So it is a free nation, but it's such a high regulation which are out there. CCPA grants some consumer rights against the people, right? So that's happened. By the way, it's also a very litigious society. I mean, it's weird. In India, we have millions of court cases that are out there, but in US, people sue each other so quickly that it's not even fun, right? For any simple things, people just sue each other. They will sue their own friends also at times. So anyway, that's separate. The bottom line here is that the regulations are being created to secure your privacy, right? That kind of thing. Somebody was asking earlier, are there no regulations around drones, right? No. I mean, this country is, like US is very, very highly regulated, but there are areas when there are no regulations. So drones are allowed, are acceptable, except when there is a secured installation. As an individual, you don't own the air above your house. So a drone can come in there and do whatever it wants. I mean, if you see that that data or that information is being misused, then you can complain, right? There are people who complain the otherwise. if you're not maintaining your house or the area around your house, your neighbors can complain to the town that this person is not cleaning their backyard, and the township will come and fine you, or they will come and clean and send you the bill. So all kinds of things happen, right? Anyway, point I'm trying to make is that regulatory frameworks are coming up, and we will see more and more regulation. Privacy preserving technique. Now, this is another area which is being talked about. This is happening in healthcare a lot. I mentioned yesterday or day before that healthcare information is very personal, especially in US, is that it's a privileged relationship between a doctor and a patient. So, lot of interesting things happened, which happened with my wife, for example. Once your son or daughter crosses 18, right, a doctor would not talk about them to your parent. Just no way, because it's now a privacy thing. So, if someone visits a doctor's office at, let's say, 17 years, 11 months, 25 days, they'll talk to you. They'll order some tests because they discussed with you and there was some issue. They order some tests. The test results come in 7 days, and now they'll say that. Now we won't tell you what came out in that. So it goes to that extreme that these regulations are there. So differential privacy basically says that let someone use a data point without ever knowing what that data is. That's called differential privacy. There's a very active area of work that is happening in this world. So what is happening there is that if you think about it, bit of a math here. We never defined algebra. I asked that question, I think, on the day 1 or 2. Here's a possibility. Can someone define what algebra is? And the reason I brought it back, because differential privacy actually defines an algebra. Is there a single algebra, or is there like multiple algebras? Multiple? Like what? Your answer is right, but tell me why and how. Okay, so if you think about it, what is mathematics? Mathematics is nothing but a system of symbols and its manipulation. Arithmetic happens to be one type of algebra where the symbols are called numbers and there are operations defined. You can define your own algebra by saying that here are the symbols and here are the operations on those symbols. Any algebra is defined by what symbols exist and what operations exist. What differential privacy does is that it defines that this is my data, this is how it will be encrypted, and these are the operations defined on the encrypted data. So any user of differential privacy or the algebra implemented by the differential privacy says that you can get hold of my data and you can do with this data these 3 operations. If you perform these 3 operations, you will get the result, but you would never see what was inside in my data, that you would not see. So the algebra is exactly the same. You define what is the symbol that you allow and what is the operations that you do. How many of you studied number systems? Right? So you're all familiar with decimal number system, which we use, right? That there is a binary number system, hex, or you can define anything. How is it different? The binary arithmetic is different from decimal arithmetic, though the symbol have the same meaning. So in a way, you're defining a new algebra where the symbols have the same meaning, but the operations have the same meaning. Addition is addition, but the symbols are different. Same way, matrix multiplication is covered by linear algebra. Symbols are linear equations. Matrix is a representation of linear equations. Operations, terms of addition, subtraction, multiplications are defined for matrices. That is not all. There are a lot of other metrics operations defined which you cannot define on the numbers, right? Inverse of a matrix, that's an operation in linear algebra on matrices, right? Norm of a matrix, eigenvalues, eigenvectors, right? And there's a whole lot of other, come on. That's where language models can come into play. Anyone notice that actually? So I have a sensor here, was this hand last week, this hand here, and it's measuring some information and sending it all over the place, including my doctor as well. All right, so anyway, so that's the differential privacy is. So what we are doing in differential privacy is that they are adding some noise. So basically saying that you would never know the real data, but you can still perform some operations on that. There's federated learning. Maybe one of you asked that question about NPU, NIU, whatever it was, NLU, which I'm not aware of, but I think it is closer to the federated learning. What is going on here is that some companies are attempting to do this, that they're saying that, so let's put it this way, whatever we studied in last 1 week or so, all the learning was done on a back end, on a server, right? So all the data was going to a central location and then learning was happening. The federated learning says that learning happens on the individual's device. So your data never leaves your device or your phone, which means that the model is only learning weights and biases based on your data. It never gets a copy of your data. That's what is federated learning. That's potentially one way of a privacy preserving technique. If your data never leaves your control, no one has your data. People have learned from it, but they don't have it, right? So that's one part of it. Two other areas we want to talk about, we'll do a little quick, transparency and explainability. So the transparency is how something is working. Explainability is that how a particular outcome or a result was achieved. Usually you have a black box problem because all these models are working as a black box. We looked into that black box last week, that what is inside, and we learned that there are neurons, there are layers, there are tokens, there are embedded tokens, there are probabilities in there, there are weights, there are biases. We learned all of this. Again, we learned the how it's working, but we don't know, we can't explain how exactly it arrived at a conclusion or why it has a certain weight or certain bias for whatever thing. Explainable AI is trying to solve that problem in the sense that this is the area of work which says that if a model suggested a specific outcome, can you find out why did it do that? Why did it arrive at that conclusion? That's what is explainable AI. Ethical implications of transparency, we're going to look into that in the sense that more open you become, more you are exposing your system for bad actors. You understand what I'm saying? Once the Google tells you how a search engine is working, a new industry comes called search engine optimization because you're trying to game the Google search engine. If you open up or make your language model transparent, because it's always learning, some people may use prompt engineering to tweak it in a way so that it will give you the results they want you to see. So that's a risk there. All right. Black box problem, usually you understand that in the sense that we talked about it continuously. It's very complex. There are billions of numbers inside the model. Every time a new word is predicted, more than 1 billion calculations happen. So it is a black box. Like even you or us who now understand how it is functioning doesn't necessarily make us any wiser as to why it's doing what it's doing. We know what it is doing, but we don't know why it's doing what it is doing, right? So that's a problem. It's an issue because if it's used by medical fraternity, for judgment, for sentencing, for law and order, people are always going to question it in the saying that how can you trust the answer given by it if you don't know how it arrived at it, right? So that problem exists. Even if we know a little bit, there is a complexity and interpretability problem because it is complex, right? One of the things that you learn is that it's taking simple words and mapping them into a very, very high dimensional space. Theoretically, if a context window is 8K, it can create a 8,000 dimension space. In general, we have not seen that. Majority of the time, people have seen 800 or 900 dimensions. Completely incomprehensible by us human beings, right? We can't go beyond 3 dimensions, right? 4th, 5th, 6th dimension, we just lost. We know that it's going almost up to 1,000 dimensions. So inherently, the model is very complex and it's very difficult to interpret what it is doing. As you increase the complexity, interpretability becomes even more difficult, right? It's very impossible to do it. And then, same thing. You want the performance, you want the complexity because you want better performance, but then you are actually trading off the interpretability. Explainable AI is trying to do a couple of different things, all active research areas. One is something called local interpretable model agnostic explanation, or LIME. Now this was a technique which is trying to explain that what is the path this prediction has taken. So, and it is trying to do that in model agnostic way. This approach actually started with data science, more for predictive models or for predictive techniques. It's been there for, I would say, good 15 years or so. Personally, I am not very enthusiastic that this will work for Gen AI very well. It might come up with something, but how useful they are, I'm not sure. Shapely explanations or shape value is a slightly better way, again based on prediction, not necessarily the right explainability technique for generative AI, but that's being used. Basically, it's saying that if you had 50 features that contributed towards a final outcome, which feature was more prominent or prominently used. But it is only saying which feature was used, it's not giving you any more information. Personally, I think we are yet to discover more or better explainability for the generative AI. A lot more to be done here. Saliency map is something that is up and coming for neural network. Now, this came from image processing techniques or from the image processing techniques. So what was happening is that when we and this was developed independent of the generative AI as part of and understand this, image processing is not new. Image processing is not discovered after generative AI. Image processing is with us for more than 50, 60 years. All metrics manipulation is image processing, and there are a lot of filters that have been used, a lot of information out there. So as part of image classification task, the saliency maps were used to identify which feature was more prominent in discovering or interpreting an image. What is going on in generative AI world for explainability? Researchers are saying that can we use these things to figure out an intermediate layer, because you saw some examples, because at each layer, each neuron, because it's a matrix, looks like an image. Can we at least explain which neuron had a higher weightage or a higher bias? So at least see which neuron actually contributed most to an outcome. This also has a relationship with what happens in our brain. Keep in mind, the entire neural network was based on what neuroscientists were finding about how brain functions. So the neuroscientists also have discovered that based on our feelings, whether it's fear, whether it's happiness, whether it's bewilderment, whether it's anything of that, different parts of the brain lit up. When they say lit up, neurons got fired. Means higher weightage was assigned to those neurons. So in a way, there seems to be some common alignment of what neuroscientists are saying, what people observed as part of the image processing, And then now they're saying that, can we use that to figure out which neuron was more active when this decision was reached? Active area of research. Again, one thing I mentioned, that more you want to know about it, more complex it becomes and more expensive it becomes. So interpretability and the cost and performance go in opposite direction. There's always going to be a trade-off. All right, ethical implications. As I mentioned, that people want to know how these functions are, how these models are working, but bad people are also interested, because if they know how they're working, they can manipulate it, right? So that's risk is always there. All right, I think the third or maybe the final issue is the accountability and governance. A lot of regulations that are coming up, legal framework, all active area. The governance models are coming up, the auditing and certifications are coming up as well. So let me go quickly and see how much we can cover. Last few slides here. Transparency, explainability, and fairness, that is what defines the accountability. Why is it important? Because of liability issues. I did not use the term liability before, but liability basically means that if something bad happens to you because of a model, who is liable, right? We saw some examples. Air Canada was fined by the court because they did not honor what their chatbot was telling their customers. So they were clearly held liable for that. But I showed you example of autonomous vehicle. If that vehicle kills a pedestrian, who's at fault? The person who's sitting in there, the person who wrote the program, person who provided the data, person who provided the camera, all kinds of things. I also mentioned to you, not part of the Gen AI, but part of these medical sensor devices, they have performed badly. I mentioned to you that I use that as an example for software design, because at the end of the day, all of these devices are using software somewhere. So even if we are not responsible, but as part of responsible programming, we need to make sure that there are enough guardrails so that these things don't malfunction, but that happens. The liability issue is still an open issue. Liability or accountability becomes a problematic because it's a black box model. So think of it this way. A company, whatever company you want to name it, Zomato, let's say, starts using the models. It has no control, because even for Zomato, the model is a black box. The base model is a black box. They may build something on top of it, either using prompt engineering or using RAG, or maybe just building a chatbot which is blindly relying on what's coming out. Are they liable for their underlying black box implementation? Open questions, right? Open issues. Algorithmic accountability. You have no control on what algorithm is being used, right? Before I came here, there were a couple of incidents reported. I don't know how many of you have heard of it or not. People falling off of bridges which were not complete, and Google Maps sent them there, or something like that. That's the story I heard. I don't know how much is the truthfulness or veracity in there. Has anyone heard of that story? Right? Same problems. Who's liable? Right? Now Google will say that as part of you using the map, you signed off on that you are ultimately responsible. We all commit that mistake. We blindly follow the path, right? I mean, I have seen in my driving behavior 25 years ago when I was going, before I start, I'll find out which path I'm taking. Now I don't. I just say that, take a left turn, I take a left turn. Says take a right turn, I take a right turn, right? Don't even bother to see where we are going. Who's liable? Question exists. Governance model, and there are multiple models being tried. Self-regulation, which is industry watchdog, government regulation, multi-stakeholder model, kind of like coming together, business trade groups, business groups, that kind of thing. Long-term ethical consideration. This is an open area in the sense that every time you provide more transparency, there's a potential of someone misusing it. All right, I'm going to skip this because I was asked to stop at 11:20, so it's 11:20. Time to stop here. Any questions? All right. If there are no questions, let me just say this again. Whatever we talked about today and to some extent tomorrow should be part of the case study that I give. Form your own opinion. There's no right or wrong answers, right? When we meet tomorrow, as I said that I'm going to tweak a little bit because there were two specific requests which were out there. One was for remote sensing or GIS, how generative AI works, and for how do you want to, if you want to create a model of your own, how exactly you do that. So I'll include those two things other than the other topics that were already to be covered tomorrow. Okay? Any last opportunity? Any questions? All right, great. Thank you. See you tomorrow.